Right, just a bit of background, computer design, basically using computers to create design and uh, s- products, parts, as well as analysis of a design. So generally, the CAD software will allow you to also simulate the design before you go ahead to make it. And it's actually one of the most basic and most often used tools for digital fabrication, especially if you talk about the complete design. Because yeah, if you take Fab Academy as example, then you start off with the mechanical physical design, then you 3D print, laser cut, or vinyl cut, you CNC it and stuff like that. Then you add on the electronics and other parts. Okay, so when you talk about CAD software, there are different categories of CAD software. These are just some examples. So you've got 2D design, so there'll be raster graphics, things like Photoshop, and then vector, these are CAD software. So these are things like Adobe Illustrator, CorelDRAW. Then you've got the 3D software. One of the differences between the raster and vector, of course, is that raster, you're looking at the individual dots or pixels of the image, and when you zoom in, you can see all the jaggies coming out. Whereas the vector graphics, they are formed by equation, and no matter what level you scale, there always be very smooth graphics. 3D software, of course, you design in 3D space, and not only that, you can do simulation with your model. So things like kinematics, the motion of the product, you can do finite element analysis, doing the loading calculation where the stresses, the weak points, as well as computational fluid dynamics, which allows you to see the airflow, heat distribution and stuff like that on your product. Then the one of the models that I put there is the graphics is a F1 car with the airflow and where are the aerodynamics of the car, where are the high pressure point, low pressure points and stuff like that. Then you've got things like the generative design. So that's the helmet looking thing with a lot of very organic looking structures. So basically for this kind of design, you just do the basic shape, then tell it where are the loads, the stress points, and then let the software remove as much material as possible, but still maintaining all your design constraints. Okay, then there are other kinds like audio, game engine, and stuff like that. Okay, so the uh, there are many kinds of CAD software. So some examples are TinkerCAD, which is very good, very popular amongst the, especially amongst the younger kids, and BlocksCAD, which is part of the TinkerCAD series, but you can write programs and scripts to generate your uh, the physical design, mechanical design. Warm Onshape is a fully browser-based CAD design software. Then there's also the Autodesk Fusion. It used to be called Fusion 360, but it's now called Fusion. The number of software like TinkerCAD is totally free for everybody. It's got very good educational resources associated with it. Same as Onshape, browser-based is totally free. But between the free and the paid version, they both are full featured, but the free version, whatever designs that you have is in the public domain. Whereas in the paid version, you can have control over who can see your designs. Then you got the Autodesk Fusion. Autodesk actually supports educators and students. So it's free for educated students, and but you have to validate your student or educator status with a 1-year license. FreeCAD Blender, they are also very powerful CAD packages. They are also totally free. Blender is also used in the motion, called animation and stuff like that. There are a lot of movies made created using Blender. Uh, of course, OpenSCAD is a scripting, a programming kind of a language. So all these are very capable 3D CAD software. But for this particular let's session, we're going to focus on TinkerCAD, Onshape, and Fusion, because I think they have a much easier user interface, easier to pick up as compared to packages like Blender or FreeCAD. Okay, so just an overview of the different software. TinkerCAD, so it's free. Again, you need an account with Autodesk. So there are different parts to it. 3D design, you can do electronics, circuit simulation. Okay, it supports the Arduino, the microbits as well. There's a simulation component where you can do physics simulation. Okay, and then a code box, which is the scripting programming part of it. So you can write code, and then when people run the program, it generates the 3D design for you. Okay, so the different modules that see down there are all the 3D design, the circuit simulation, as well as the SimLab simulation and the code blocks. Okay, I've put in a couple of links to resources for TinkerCAD. So that's where you can, if you want to learn further how to use the software, you can just click on the links there. There are educational lesson plans, the Learning Center from Autodesk itself, and then HL Mod Tech. This guy is a YouTube channel. He's got very nice, comprehensive lessons on learning how to use different aspects of TinkerCAD. So well worth a look if you short of ideas. Okay, so Onshape, again, full feature CAD software, free for all. If you are using the free version, of course, designs are public, and it's totally browser-based. There's no installation at all. All what you need to do is just register for an account. Because it's browser or cloud-based, that means you can work on collaborative designs. So as an educator, you can actually create an account and then uh, open it up to your classrooms, to your students, and share files with them within that environment. Okay, because a lot of people are using it free, so their designs are in the public, and you can search through for different kind of designs, and there's also a timeline history to it, parametric, so you can actually learn from the design of other people. Of course, it's got a very wide collection of apps and applications and feature script. Yeah, so for instance, if you are doing 3D laser cut design, there's actually a feature script that you can put in there that simplifies the whole design of the finger joints for 3D laser cut products. And there's also another feature script that allows you to lay out all the parts after you have designed it. All right, so the link there are resources for learning, including the curriculum and stuff like that. Okay, Autodesk Fusion, full-featured, free for students, educators. As an educator or student, you have access to the full package, which costs about 700 for us here per year. Okay, designs are saved in the cloud, so basically means that you can access your designs from anywhere so long as you have internet account. And there's also a browser-based component, a browser-based version of it. I've tried using the browser-based a couple of years back. Didn't quite like it. It's not as good as the desktop install version available for Mac and Windows as well. So one of the things about Fusion is that they have different workspaces. So it is a comprehensive package. You can do 3D design. You can do a sculpting, like a plasticine, and then you start extending it, molding it to shape like a paintbrush kind. Can do rendering for presentation, animation of your design. There's a CAM component as well, so you can do CAM, two-path, and CNC of your design. Okay, so there's also a generative design component. And between the TinkerCAD and Onshape or the Fusion. Fusion is a full feature package, so and Onshape as well. So if you're doing the product design where you need a very accurate dimensions and stuff like that, I find it personally a lot more useful than working in TinkerCAD. There are a lot of things I want to do in the design. Okay, if I'm using TinkerCAD, it's like I'm working with one hand tied behind my back. Whereas with Onshape Fusion, you have got access to a lot more tools and features. And because of that, because of power, sometimes it's more suitable, for, I guess, for the older kids. We have tried teaching Fusion to secondary school. That means grades maybe 7, 8, 9, 10 kind. Yeah, they can cope with it. Young kids younger than that, we haven't tried that yet.